So this presentation is centered on understanding Louisiana Student Standards for Science Scope and Sequence document. In today's presentation, we are going to focus on helping you dig deep into the scope and sequence documents. Specifically, we will evaluate the sample scope and sequence documents, describe phenomenon-based instruction, help you determine if a phenomenon is instructionally strong or weak, and describe how to use natural phenomenon and the scope and sequence documents to drive classroom instruction. Before we get started, the very first thing that we are going to do is look at the key instructional shifts that we have highlighted to align with the scope and sequence documents and our new science standards. On the right side of your screen, you will see a file box. In the file box, you will see a document titled Shifts in Science. If you would download that document, we will be using it throughout today's presentation. Louisiana Student Standards for Science represents the knowledge and skills needed for students to successfully transition to post-secondary education and the workforce. When we begin to create documents to support Louisiana Student Standards for Science, we thought about three key things that we wanted to see in science classrooms. And we developed these three key instructional shifts to help teachers as well as administrators know what to look for in science classrooms. So the very first thing that we expect with the new standards is, number one, students should have the ability to apply content knowledge. Number two, students should investigate, evaluate, and reason scientifically. And number three, students should have the ability to connect ideas across different disciplines of science. If you would, please analyze the shifts page. And in the check box, define what each of these shifts mean for you and what you would expect or what you will be looking for specifically in your classroom with the instruction of the new standards. I'm going to give you 2 minutes to review the shifts document, and then we'll move on. Now that you've had an opportunity to analyze the shifts page, in the chat box, I would like for you to define what each of these shifts mean. Thank you all. I see some wonderful responses over the chat box. So I want to start with shift number one, applying content knowledge. As many of you have said, instead of students just regurgitating information or recalling information that they may have been taught in class, with this key instructional shift, we are looking for students to apply content knowledge to real-world scientific phenomenon, either phenomenon that they are currently studying in the classroom or new scientific phenomenon that they may have never been exposed to. And so historically, what we've seen in science classrooms is that teachers dominate the discourse and teach content knowledge and encourage students just to regurgitate or recall key ideas. And with this shift, we want to move away from that. The second key instructional shift, investigate, evaluate, and reason scientifically, directly ties into our science and engineering practices, which is the first dimension of our standards. And so instead of students just sitting and receiving information, we now want students to begin to engage in and begin to mimic the behaviors of both scientists and engineers. So what feels really, really different for me with this second shift is that this is the first time that students will actually be responsible for taking on the role of an engineer in science classrooms. The last shift, which directly connects to dimension number three of our standards, the cross-cutting concepts, students should have the ability to connect ideas from lesson to lesson, unit to unit, and even grade level to grade level. So as students are going from different science disciplines, so from life science to physical science to earth science, they should be able to see that the cross-cutting concepts are applicable across all of those different dimensions. So the instructional shifts here is really important for us because as we develop the science scope and sequence documents, we have these key instructional shifts in the back of our mind. So as we continue with today's presentation, I want to be sure to point out to you how the scope and sequence documents are supporting students' understanding of these three instructional shifts. But before we do that, I want to spend some time talking about phenomenon-based instruction. And so the first question is, what is phenomenon-based instruction? Phenomena are observable events that occur in the universe and that we can use our science knowledge to explain or predict. Historically, we have taught science ideas or science topics. And now, instead of just teaching key science ideas or topics, we want students to have an opportunity to make sense of scientific phenomenon by trying to figure out how or why the phenomenon is taking place in the real world. So historically, we've taught ideas such as planets revolve around the stars. And so instead of just teaching that idea, we can now help students root their understanding of that idea by using a phenomenon such as the fact that Mercury has orbited or traveled around the sun. And this occurred in 2012, 2016, and they are predicting that it will occur in 2019. A second key idea that we have historically taught is that species evolve over time. And so as students are looking at this key information, they can now look at the fact that smart moths have evolved to fly away from city lights. Again, they're still learning the same content knowledge, but instead of just learning about the topic of evolution, they can now apply that content knowledge to a real-world phenomenon. And then lastly, students can look at the fact that water on Mount Everest does not boil at 100 degrees Celsius and use the universal gas law to explain how and why that is actually taking place. So in the Louisiana Student Standards for Science Scope and Sequence documents, you will see phenomenon-based instruction used throughout the documents to help support students' understanding of key content knowledge. So some examples of that. In the 4th grade, students look at Louisiana's disappearing coastline. And as they are looking at this phenomenon, they are actually rooting and understanding in trying to explain how weathering and erosion is contributing to Louisiana's disappearing coastline. In middle school, students look specifically at the bleaching of coral reefs, and as they are looking at this phenomenon, they are studying interdependent or symbiotic relationships in ecosystems. And then lastly, students in high school look at an ice calving event where a glacier the size of Manhattan begins to break apart as they look at global temperature changes and the greenhouse effect. So what I would like for you to do is to have an opportunity to explore some of these anchor phenomena before we move forward with today's presentation. To the right of your screen in the web links box, you will see 2 links. The first link is to the 4th grade example of Louisiana's disappearing coastline. And you'll also see a link for middle school where you can look at the bleaching of coral reefs. Both of these phenomena are incorporated in our scope and sequence documents, and I would like for you to click on those links and see those videos. So take 2 minutes to review those 2 videos. After you have had an opportunity to review the videos, I would like for you to come back to the chat box and discuss how scientific phenomena, such as coral reefs and Louisiana's coastal erosion, helping students understand key science ideas. I'm going to give you 4 minutes to look at the videos and to respond to that prompt. We have about 1 minute remaining, so if you haven't started typing in the chat box to discuss how scientific phenomena will help students understand key science ideas, please begin to do so. Thank you all for the wonderful responses. I'm going to read some of them out loud. So Tana mentioned that students making connections to land loss in Louisiana will allow them to connect what they learn about the ongoing processes of weathering and erosion to our state and the problems we face due to these natural processes. Diane mentioned that both videos have visual elements that connect with students emotionally. The connection with our state provides a real-world connection that Louisiana students can connect to. And Cal states that phenomenon will help students understand key ideas because the phenomenon sets a purpose for learning. Students will apply newly introduced content to a new situation. This content is connected to something that a student has experienced and provides them opportunities to come up with their own reasoning and questions. And I agree with all of you. So phenomenon-based instruction is beneficial to students because it helps them connect what they are learning to real-world phenomenon, to real-world things. And also in fourth grade, this is a wonderful anchor phenomenon because fourth grade students can definitely connect to the state of Louisiana because it's the state in which they are living. So when we talk about why use phenomenon-based instruction, a lot of you have hinted from your responses the importance of phenomenon-based instruction, but I want to quickly go through just 3 key things on why we feel like phenomenon-based instruction is important for students in Louisiana. So past science instruction has just focused on teaching general knowledge. And now with phenomenon-based instruction, students not only build general science knowledge, they build it in the context of their application to understanding phenomena. Secondly, we failed to clarify why students needed to learn key content knowledge in the past. And now with phenomenon-based instruction, we are supporting students' agency for wanting to build science and engineering knowledge. So if I'm a fourth grade student and I am learning about Louisiana's disappearing coastline, after I have gone through a series of investigations, I now see the importance of being an engineer and putting on that engineering hat and trying to figure out and design a solution to overcome the issue of Louisiana's disappearing coastline. And then lastly, we focused on teaching just specific topics. And now instead of just teaching a topic or idea, we are helping students figure out what or why something happens. So this shift is very different for both teachers and students. And we have these ideas in the back of our mind as we begin to develop Louisiana scope and sequence documents for science. So in the scope and sequence documents, you will notice that we have highlighted an instructional process. And within the instructional process, we have specifically evaluated what students should be doing and what teachers should be doing. So as we go through the remaining portion of the presentation, I'll be sure to emphasize when students are doing a lot of the heavy lifting and when teachers are doing a lot of the heavy lifting. So in the scope and sequence document, you will see these 6 key instructional practices that we have placed within the document. The first step is that students explore the anchor phenomenon. The anchor phenomenon is used on a unit level and it covers 2 to 5 performance expectations. It's very broad in the sense that several different topics can be taught throughout the unit of study. In the second step, students attempt to make sense of the phenomenon by eliciting questions surrounding different artifacts that the teacher may present to them. Number 3 is where the teacher comes in during the planning portion of his or her lesson on the unit level and begin to identify related phenomena. Number 4, after they identify related phenomena, they develop questions and next steps using the standard document pages. So the questions that they specifically develop should be directly tied to the content knowledge that's required from the sample scope and sequence documents or from the, the performance expectation. In step 5, after teachers have gone through this planning phase, students are now ready to explore investigative phenomena to make sense of the anchor phenomenon. Now the investigative phenomena is different from the anchor in that it only addresses one key idea or 1 to 2 portions of the anchor phenomenon. In step number 6, students communicate scientific reasoning around the anchor phenomenon. So we're going to go through all of these different steps to help you think deeply about each step and what's involved in each step. So if you look to the right of your screen, in the web link box, you will see the 4th grade scope and sequence document. If you would download that document, we will be using it for the remaining portion of today's presentation. Once you review, once you download the 4th grade scope and sequence document, I would like for you to review the first couple of pages just to see how the document is organized. Once you review the first few pages, I would like for you to focus in on pages 7 through 9. That is the About the Standards section of the first unit. As you are filtering through that unit, I would like for you to consider the following questions. How is the About the Standards section supporting Louisiana Student Standards for Science instructional shifts? In the chat box, I would like for you to discuss the key portions of the About the Standards section that stand out to you. So in the chat box, Tana has replied that the About the Standards portion of the scope and sequence documents let teachers know which standards are covered by the phenomenon, both partially and fully. It addresses all three dimensions by unpacking the disciplinary core ideas, as well as describing the connections of the science and engineering practices and cross-cutting concepts. And I also see a few people are beginning to respond. So I'm going to give you a moment before I start talking so that everyone can get their responses in. So when we're looking at the About the Standard sections, I agree with Tana. And what really feels important to me here is that you see all of the performance expectations that are bundled together in the unit of study, and you also see the partial unpacking of the disciplinary core ideas. When you are reviewing the standard document pages, the disciplinary core ideas that are listed do not specify all of the content knowledge that students need to know and understand to be prepared for the end-of-year performance expectations. So it's very important that teachers understand that there are several different pieces of content knowledge that they need to teach in order to get students to that end result. And so the unpacking portion of the disciplinary core ideas was specifically designed to help teachers see all of the content knowledge that need to be taught to get students to that end result. The second portion that I will point out are the science and engineering practices. So all of the practices that are addressed within the first unit of study are highlighted here. But again, when you look at the standard document pages, you will notice that all 8 of the science and engineering practices are listed on the standard document pages. So it's very important to understand that all of the practices should be continuously stressed and continuously used throughout daily and weekly lessons. But when it comes to formative and summative assessments, teachers really want to make sure that students have a deep understanding of the practices and cross-cutting concepts that are highlighted within the About the Standards section before moving on to the next unit of study. So that brings us to the very first stage of the instructional process, which is exploring the anchor phenomenon. Now, before we dig deep into what students are doing during this first segment of the process, I want to make sure that I'm also giving you an opportunity to look at how we have selected anchor phenomenon. So on page number 3 of the standard of the scope and sequence documents, you will see a segment titled Choosing an Anchor Phenomenon. I would like for you to read over that list, and as you are reading over the list, I would like for you to assess the anchor phenomenon that is on page 10 of the 4th grade scope and sequence document. Your job is to identify or to determine if the anchor phenomenon is instructionally strong or weak based off of the checklist that is on page number 3. After you have had an opportunity to assess, in the chat box, I would like for you to respond to question number 2. Is Unit 1 anchor phenomenon instructionally strong or weak? Why or why not? I see several of you are beginning to type into the chat box. I'm going to give you an opportunity to get your responses in before we move on. Awesome. So thank you all for responding. So based off of most of the responses, well, all of the responses. Everyone has pretty much replied that this is a strong anchor phenomenon for several different reasons. I've seen everything from it engages students, it's a case study that has relevant data. It also is very puzzling in that students won't be able to quickly identify how or why it's occurring, or discuss all of the different things that that's causing the disappearing of the Louisiana coastline. This is very important to me, or the number one bullet point that's important for me as we approach, or as you approach identifying anchor phenomenon, is bullet point number 3, is that the anchor phenomenon has relevant data, images, and text to engage students in the range of ideas needed to understand it. It should allow them to use a broad sequence of science and engineering practices to learn science through first-hand or second-hand investigation. Remember, at the end of this entire process, step number 6 in this process is for students to be able to communicate scientific reasoning around the anchor phenomenon. If we do not present students with relevant data, images, and text, they will not have the scientific knowledge to be able to communicate how and why the anchor phenomenon is occurring. So it's very important when you are selecting an anchor phenomenon that you ensure that there is enough scientific data to help students understand it and to help students be able to explain it scientifically. So that brings me to page number 10 of the 4th grade scope and sequence document. What you will notice on page number 10 is that we have listed a number of different resources that teachers can use throughout the entire unit of study. These resources are not designed to be used over the course of 1 or 2 weeks. Instead, these resources should be used over the course of 4 to 6 weeks. Teachers will need to assess the content in each of these resources and each link to determine when the resource should be used throughout the unit of study. What we don't want to see happen is that teachers show students all of the videos, have them read all of the non-fictional text in one sitting or in 1 or 2 lessons, and take away from them truly exploring and investigating the phenomenon. During the Explore section, we want students should be puzzled. Students will have limited scientific understanding of the phenomenon, and they will not be able to explain key vocabulary terms or key knowledge surrounding how and why the anchor phenomenon actually takes place. And that's very intentional on our end, because we want students to begin to pose questions surrounding how and why the phenomenon is actually taking place. So the next slide specifically states that students should be able to make sense of the anchoring phenomenon, but not immediately and not without investigating it using sequences of the science and engineering practices. With instruction and guidance, students should be able to figure out step by step how and why the phenomenon works. The role of the teacher is to select the resources that will help students understand how and why the phenomenon is occurring after they go through those series of investigations. So that brings us to the next phase of the instructional process, which is step 2, where students try to make sense of the anchor phenomenon. Step 1 and step 2 are very, very closely linked to one another. So what I would like for you to do is to begin to review the next section of the scope and sequence document. I want you to review the questions students may pose that could be used for future learning or investigations on page number 10. And I want you to answer question 1 and 2 in the chat box. So question 1 states, number 1, are these questions that students may actually pose? Why or why not? And then number 2, I want you to begin to think about how can teachers use the questions that students pose to shape the unit of study. I'm going to give you some time to read through the questions and to respond to those 2 prompts. Thank you, Kyle, for your response. I see that several people are still typing. I'll give you an opportunity to finish up your writing before we move forward. So I want to read some of your responses out loud to help guide our discussion surrounding how these questions can be used to shape a unit of study. So Crystalline specifically states that some of these questions may be posed depending on how exposed students have been to this phenomenon. The questions may be more surface, but lead to the same information. Teachers can use these questions to ensure that the depth of the standard is covered. Teachers should plan for these questions to guide student inquiry. And so I want to start here because I agree with you, Crystalline, in that some of these questions students may pose depending on who they are and what part of the state they are living in. So for example, the first question, what is causing the Louisiana coastline to disappear? I think that several students may pose that question. But depending on what portion of the state that students live in, they may not pose question 4. How do natural hazards such as hurricanes and flooding impact Louisiana's coastline? So some of our students that live in the southern portion of the state may consider natural hazards such as flooding and hurricanes. But some of our students living in North Louisiana may not consider hurricanes to be actually contributing to Louisiana's disappearing coastline. What's very important here is that teachers understand that some of these questions, they may have to put artifacts in front of students to get them to begin to elicit some of the questions. So can maybe teachers in North Louisiana put pictures of flooding during Katrina or pictures of flooding during the 2016 floods to get students to begin to ask, how do you think this is contributing to Louisiana's disappearing coastline? So throughout the responses throughout the chat, I'm seeing several people say some of the questions, maybe portions of the questions may be asked, and I agree with you. The role of the teacher during this portion of the scope and sequence document is to put different artifacts in front of students to get them to question how and why the phenomenon is actually taking place. The second part that some of you mentioned is that students may not use key vocabulary terms. Students may not ask every portion of the question. That is okay. What's important here is for teachers to know and understand that this is some of the content that will be addressed throughout the unit of study. After students pose questions, teachers can then begin to bucket those questions into questions that students can investigate, questions that address this portion of the performance expectation, or maybe address another performance expectation, and begin to shape the unit of study based on students' questions. What's very important is that as students are shifting throughout the unit of study, that they have an opportunity to go back and answer the questions that they posed at the beginning of the unit. After students try to make sense of or begin to pose questions surrounding how and why the anchor phenomenon occurs, the next step is where the teacher comes in and begins to identify related investigative phenomena. A good investigative phenomenon is one that helps students to make sense of one or two parts of the anchor phenomenon. It is very specific in that students will be able to understand one key portion of how or what's causing the anchor phenomenon to take place. So for example, one investigative phenomenon that students look at is that water causes erosion. So teachers may go through 1 to 2 lessons where students are looking at that one specific factor that's contributing to Louisiana's coastline. The investigative phenomena still have relevant data, images, and text and help to engage students in learning. So during step number 3 and 4 of this process, teachers identify the phenomena and they begin to develop questions and next steps around the phenomenon. So the very first thing that I would like for you to do for the next portion of the presentation is I want you to look at pages 11 and 12 of the 4th grade scope and sequence document. On pages 11 and 12, you will see that we have highlighted 5 key sample investigative phenomena that will help students understand and make sense of the anchor phenomenon. I want you to, as you are looking at these 5 examples, I want you in the chat box to respond to question number 1. How are the investigative phenomena helping students make sense of the anchor phenomenon? And I'm going to give you about 2 minutes to review all of those, respond in the chat box, and then we'll go on to the next portion of developing questions and next steps. I see several people are beginning to respond. Thank you to Crystal and Leslie so far for responding, and I see several people are typing in the chat box. So I'll give you some time to continue to get your responses in. So thanks to everyone for responding. I still see a few people are getting their some last-minute feedback in there. But I want to talk specifically about how the investigative phenomena that we've selected on pages 11 and 12 of the 4th grade scope and sequence document is really helping students understand the anchor phenomenon. But before I do that, Leslie mentioned that looking at the Grand Canyon example should help students generate connections between different rocks and rates of erosion, and teachers must help to make a connection with the Mississippi River so students can recognize how coastlines are formed. Each example can be built upon using reflective questions and the disciplinary core idea breakdown. And I agree with you, Leslie. If we look at sample 2, the investigative phenomenon for sample 2 states that the Colorado River carved the Grand Canyon. And like Leslie stated, I think that a lot of students in classrooms will begin to connect that just like the Colorado River have carved out the Grand Canyon, that the Mississippi River or other bodies of water that may be close to them has contributed or is contributing to Louisiana's disappearing coastline or erosion close to them. And so what's really important here is that when we're looking at sample 2, I want to draw your attention to the 3rd question underneath sample number 2. What do the formation of the Grand Canyon and the disappearance of the Louisiana coastline have in common? How are they different? It's very important that teachers are making and helping students make those connections between the investigative phenomenon and the anchor phenomenon. If teachers are not explicitly helping students make those connections, then students may not have an opportunity to make those connections. So I will strongly encourage you in your classrooms to make sure that you are setting aside time to help students make those connections. And the key word there is that students should be making those connections. Again, you may have to put artifacts in front of students to help them make those connections, but if we do not go back to the anchor phenomenon throughout instruction, students will never be able to make sense of how and why it's taking place. So you will see throughout the scope and sequence documents that we have strategically put questions to help teachers, help students connect their understanding of the investigative phenomenon back to the anchor. So now that we have had an opportunity to look at the investigative phenomena, the next step that I want you to look at, or the next step of this process, is for teachers to develop questions and next steps. I want you to review the questions that's underneath each of the investigative phenomena. To the right of the screen, you will notice in the web link box that I've linked the Louisiana Student Standards for Science. I would like for you to download that file, go to the 4th grade performance expectations, and I want you to review the performance expectations that's linked to this unit of study. As you are looking at the standard document pages, I want you to see if you can connect how the questions are directly supporting the key content from the performance expectations or the standard document pages. All of the questions that we have designed was specifically designed to support that content within the performance expectations. I know that task is pretty involved, so I'm going to give you about 4 minutes to download that file, to take a look at the questions and see if you can begin to see how the questions are connected to the standard document pages. Perfect. So let's go ahead and jump in to look at how the questions that we have formulated on pages 11 and 12 underneath each sample is supporting the performance expectations. I love the comment that Leslie made that each particular question can be linked to a part of the standard. In doing this, learning is explicit in nature, and teachers can guide how students are learning and address any misconceptions about key ideas and concepts. And so that was our number one objective in developing the questions using the performance expectations. Allison, Tana, as well as Karen have specifically pointed out performance expectations that we have used throughout on pages 11 and 12 as we develop questions. But I want to draw your attention to sample 1. Different types of rocks and sediment react differently to wind and water. The cross-cutting concept for this sample investigative phenomenon is cause and effect. And if you will notice that the second to last question is leading teachers and students to discuss cause and effect relationships. It states, how does the amount or force of water impact different materials? This question was specifically designed to help students see cause and effect relationships. But what's very important here is that teachers have to explicitly call out this cross-cutting concept and make sure students know that this is a cause and effect relationship, and that they will see cause and effect relationships in sample 2, 3, and 4 investigative phenomenon, as well as throughout other units of study and other grades. And so what's really important here is that when we get to the cross-cutting concepts, that we are explicitly helping students make those connections. The second thing that I will point out to you in regards to three-dimensional learning is tied to sample number 4. Hurricane Katrina dramatically increased the rate of land loss in the year of 2005 when compared to other years. The last question, is there a pattern to the formation and path of hurricanes, is a two-dimensional question. And so you will notice that all of the questions are either two-dimensional or three-dimensional in nature, meaning that they either address the science and engineering practices and disciplinary core ideas, the disciplinary core ideas and cross-cutting concepts, or the science and engineering practices and cross-cutting concepts. It's very important that as we approach instruction that we are teaching the standards and interweaving all three dimensions into instruction. A lot of teachers will want to teach one dimension and will want to teach the dimensions separated, but I'm going to strongly encourage you to interweave the practices, cross-cutting concepts, and disciplinary core ideas throughout instruction. So that last question, is there a pattern to the formation and path of hurricanes, is two-dimensional, and that pattern is the cross-cutting concept that's being addressed in that investigative phenomenon. And the formation and path of hurricanes is addressing a disciplinary core ideas surrounding natural hazards. So as you are approaching instruction, please make sure that you are teaching two-dimensional and three-dimensional. Moving on to the next step. After students have had an opportunity to, after you have developed questions and next steps, the next step is for students to explore the investigative phenomenon. Students should explore the investigative phenomenon using the science and engineering practices and cross-cutting concepts. What's important here is that as a teacher, you are not standing in front of students and doing a lot of direct instruction. But instead, students are doing the heavy lifting in class and have an opportunity to truly explore learning. After or as students are exploring learning, you should introduce key vocabulary terms or scientific reasoning behind how and why the investigative phenomenon is taking place. And this is where you want to use some of the resources that are listed on page number 10 to support instruction. The last step of the process, after students have had an opportunity to go through a series of investigations, the very last step is where students should be prepared to communicate scientific reasoning around the anchor phenomenon. On page number 13, you will notice that there are 2 sample anchor phenomenon reflections that students can complete. The first question states, describe the impact of living and non-living things on Louisiana's coastline. And question number 2 states, generate 2 different solutions to Louisiana's disappearing coastline and determine the strengths and weaknesses of both proposals. As students are completing these reflection questions, it's important that they are using evidence from out of the series of investigations that they have completed. So they can use non-fictional text. They can use evidence from models that they have created. They can also use evidence from investigations that they have completed. And so what's important here is that you make sure that your students are supporting their responses to these questions using evidence from the entire unit of study. The next part of what I'm going to go through is our implementation support for Louisiana Student Standards for Science. All of the documents that are hyperlinked have been released by the department, and over the next few weeks we will continue to release the remaining instructional tasks as well as updating the sample scope and sequence documents. In addition to the implementation support, our assessment team have released some guidance on what the field test assessment will look like. I'm going to share the next few slides with you, but if you do have any direct questions dealing with assessment, you should reach out to assessment@la.gov. So all students will take the LEAP 2025 science assessment starting in the 2018-2019 school year. Questions have been reviewed by Louisiana educators to ensure that they are aligned to the new standards. The field test assessment will be a set-based design. A scientific phenomenon will provide the focus for the sets. A stimulus or stimuli material will describe the scientific phenomenon. You will have where several different questions, 4 to 5 questions, will be surrounding the phenomenon, and students will use the stimuli and course knowledge to answer the questions. In addition to that, you will also have item sets with selected response and 2-part questions. Some sets will culminate a 2-point constructed response item. You will also have test sets and discrete items. For grades 3 through 8, we will not have any type of operational assessment, but students will take a field test assessment, which will be comprised of 2 sessions, and those 2 sessions will be timed. Students in grades 3 through 4 will have the option to take a paper-based assessment. All of the information that I am discussing can be found in the science field test overview, which is linked here. For high school, in high school, the biology EOC will remain operational, and within that EOC, you will have some field test items will be in.
This has been a presentation of the Louisiana Department of Education, copyright 2017, all rights reserved. For more information or to contact the Louisiana Department of Education on the web, go to www.louisianabelieves.com or call 1-877-453-2721.